Okay, so the next problem in the lead code we are solving is combination sum. Okay, so basically, what's happening here is like we have given the candidates. Okay, like we can say just a numbers. Okay, numbers, and we need to build the different combinations such that we are going to get this target sum. Okay, so basically, what's happening here is again. What we are trying to do here is we are trying to do the different combinations and getting the sum here. So as you can see directly here, right? We can we can actually repetitively add the same number. Okay, we can repeatedly add the same number, but order should not change. Like it should be unique. Okay, let's say that 2 to 3 is valid, but we cannot say like again 3 comma 2 comma 2. This also results in the same, right? 7, but this is not valid, so it should be only one. Okay, so it should be unique. Okay, so now this is the problem about we have been given the candidates, and we'll have to generate a different combination such that if we take a sum of it, right, it should result in the 7. Okay, so now how are we going to do it here, right? So basically what's happening here is we are trying to build a different combinations, correct? Whenever there is a problem about combinations like and all these things, right, combinations, we'll simply go with the backtracking. So like we are going to try the different combinations, right? So we'll go here and we'll try something. Once the edge condition is met, we'll come back and we'll try something else. So that's in that way, like we can try the different result. So that's why we are going to use the backtracking here. And backtracking is nothing but a recursion, right? Backtracking is nothing but a recursion here. And whenever there is a recursion function, there should be an exit condition. This is like a formula kind of thing. Okay, so what is the exit condition here? Has been given that 7, right? So once we have built some list, let's say that x comma y comma z, right? We are going to take a sum of it and let's see if it is equal to the target. If it is equal to the target, then means we are good, correct? And also if it is going exceeding, right? Like if it is going exceeding the 7, it means we are going in a wrong way. So we'll have to stop it there. We'll have to stop it there. That will come back here. Okay. So and also this will be our exit condition, correct? This is the exit condition. And also we need to make sure that whenever there we are backtracking, we need to send what we have done so far to the child recursive functions. Okay, so let's say that we have done some calculation, and child recursive function will rely on what we have done so far. Okay, so whatever, let's say that I have built initially I have took 2. Okay, I will have to send it to the child recursive call. Okay, so what it will do is it might add one more to it, and finally it might another child recursive call will take in and pitch in, and it will add one more 2. Okay, so this is how it was going to do. So ultimately when you see this one, right, 2 plus 2 plus 2, so it is still valid, correct? It is not reaching the 6 one. Again, what another child calls will do is it will try to add 2 comma 2 comma 2 comma 2. Okay, so what will happen now? Target is equal to 8, which is greater than this one, right? Like which is greater than the target, so this is not valid, so this will be removed. Okay, so what we are going to next, what it will do is it will try the new next value, next possible value, that it will add the 3 here. So now what will happen? 2 plus 2 plus 2, 4 6 plus 9. Like again, this is not a valid. Ultimately, like it will try 6 also, 7 also, it won't be valid, right? So once this is it's not, everything is not valid, so it will come back as it's a backtracking, right? We'll come back one step and we'll try this one now. So now what will happen? This will be a valid string. 2 comma 2 comma 3 is a valid string, so we'll add it to the result. Okay, so now let's see how we can implement in the code. Okay, so basically, as we discussed so far, we are going to use a backtracking function because we are generating a combinations here. And whenever we are doing the backtracking, we need to tell the child recursion so far what we have built. Okay, so that it can use it to continue it further. Correct. So backtracking basically here we are going to try out all this combination, right? Just by visualizing it, we know that we'll have to try out all this, like sometimes 2 plus 3 plus 6 and everything, right? So that's why we are going to use a for loop here. Okay, before actually going there, we'll need to know understand the exit condition first. Okay, so far we have built some combination. Okay, and we know what is the total. Actually what we can do is, right, we can without this total also, what we can do is we can whatever the so far we got, right, we can take a sum of it. Okay, we can take a sum and check if it is equal to the target or if it is greater than target. If it is equal to target, we'll add it to the result. If it is greater than the target, we'll just stop it there and return back, right? We can do that, but that will every time taking a sum will be time complexity. It will increase the time complexity as the list grows, right? So what we can do is we can keep a track of this one, like whenever we add a new number, right, we can build that list and send it to the child recursion. So far this is the list and this is the total for it. Okay, this is the sum, this is the total for it. Okay, we can use that for the calculation of the exit condition. Okay, so now what we are going to do here is so let's say that as we are not allowed to go back, right, so we'll have to tell that from where we are allowed to take the index actually. So let's say that if I don't send the index, right, every time I run a loop, It should not be like I should not be doing the like I mean, as we discussed in the beginning, right? It should not be in this order. Like it should be in one order, and it should not be repetitive. So what does it mean is, let's say that we are trying to build a combination out of this, right? It should always be like this: 2 comma 3. It can be self actually, or it can be forward. It should not go behind, right? So let's say that if I start building, let's say that if I'm picking this number as the first one, right? I shouldn't be writing it like 3 comma 2, because 2 comma 3 is already validated. Like, because when I was evaluating this one, right, I might have already considered this, so I should not be going backside. I should be going only forward. Okay, so that's why this index is essential. Okay, so to build a combination, to avoid the duplicate, this index is essential, and we are going to build a new combination only starting from there. Okay, so initially when we are starting the backtracking mechanism, so far I don't have anything. Okay, I don't have any combination sum, and we are going to start from the zero, right? We are going to start, like I mean, we are going to start generating combination from here, right? So basically it will be like, I can write it like 2 plus 2 plus 2 plus 2. Once it doesn't work, I can go to 3. I can 2 plus 3 and 2 comma 3, like all these kind of things, right? But when I'm evaluating a combination for this one, right, let's say that for the first time I'm going to pick the 3. Okay, if I pick the 3, I'm not allowed to take the 2. So I need to start from here only. So that's why we have this range actually. So we are going to we are not going to get the numbers which are already evaluated. We are going to see only that are represent next to it. Okay, so this is it. So we have an exit condition here, and we are going to backtrack it with the different combinations. So far whatever is done, we are going to add the new candidate, whatever the candidate that we get, right? This is an index actually, not actually a candidate. So we are going to read it here. Like I mean, candidates based on the index, we are going to read the value for the candidates and append it to the list, and then send it to the child recursive function. There it will, the evaluation will happen whenever we had a new candidate number, right? We will make sure to update the total. Okay, like I mean, the new total that will be used in the exit condition. Yeah, that is it. Thanks.